Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. This is 12 volt power supply. I shared a procedure to adjust the voltage to our required voltage. It was 12 volt, now it is providing 14.2 volt. I explained the method how we can select the resistor, and then I discussed what are the disadvantages of this modification. If you can compromise on this loss or this disadvantage, then you can do this modification. Otherwise, I will recommend never play with any design. If we will modify it, that time we will degrade it. We will derate its output power. Let's discuss in detail. We will see how we can adjust output voltage, increase or decrease. If you don't have good practical experience in electronics, never do this experiment because there are live electrical voltage. It is providing 12 volt output. We want to increase up to 14.2 volt. This is a question from my viewer. Dear sir, how we will find R1 plus R2 value when output is 14.2 volt? Please explain. My viewer did not describe how much voltage are there. Normal output 12.06 volt. Never touch any component when the voltage are supplied. Check voltage on these capacitors. If there are voltage, discharge them properly, then touch to the circuit. Because here is bleeder resistor, so it is discharging the capacitors. Wait until the capacitors are discharged. Now we need to check output side. It is using TL494 secondary side regulator. If it is using TL431 or any type of regulation, just to locate output side voltage. Now if we check here, this is positive output point. At positive output point we have one resistor here to this point, then this resistor, it is coming back to this point, then this resistor, then this variable, and it is ground pin. Two resistors here, one resistor here, this variable. This is 6.8K, 680 ohms, 1500, 1.5K and 1K, 102, 1.5K, 6.8K, 680 ohms, and this capacitor in parallel as a ripple remover from the positive line. 333J. One resistor, second resistor, this is 6.8K, 680 ohms, 1500 ohms, 1K. This end is connected to ground, this is connected to positive voltage. Here is capacitor. And this is output point. This point is reaching to IC. From here it is going to IC feedback pin. So we need to adjust these resistors. Now we will check voltage across these two resistors from positive point and this point. Always take care for the safety. How much voltage are dropped across these two resistors? That are these 2 points. 9.6 volts. Normal voltage 12.0. Normal output 12.07 volt. Out of 12.07 volt, 9.6 volt, 9.606 volt are dropped across these 2 points. .606 and remaining voltage from this point to ground 2.48 volts are dropped across these 2 points. 2.482 that are dropped across these 2 points, these 2 resistors. 12.07 volts minus 9.606, 2.464. That are dropped across this lower 2 components. Here we have 2 resistors, 6.8K and 680. 9.606 volt are dropped across these 2 resistors divided by, because I is equal to V over R. Voltage are 9.606 and resistor is 6800 plus 680 ohms. It is 0.001284, 0.001284 ampere. Move decimal point to here, 1.2842 milliampere. This is current flowing in this node. Now we need 14.2 volt that are projected voltage, that are required voltage. Out of 14.2 volt, 14.2 minus this voltage 2.482, 11.718, 2.482, 11.718 volt. Now previous voltage drop was this one, but now new voltage drop will this. We need to increase the resistor value here. 11.718 divided by this current value, 1.2842. It is 9.124. R is equal to V over I. Voltage are 11.718 volt. Current I is 1.2842 milliampere. When current in milliampere, resistor value is 9.124 kilo ohms. or we can multiply with 1000. So 9124 ohms resistor we need. We have two resistors here. The first one, that is 6.8k. So we need to replace just only this resistor, 680. 9124. This is our required value here, resistor value, minus 6800. We need 2324 ohms more instead of this resistor. 2324 ohms resistor we need to place in this point. We will remove this one and we will install this resistor. 2.2k. We will try to locate some closer value. 2.15. No, we don't need this, we need more resistor. 2.5. This is slightly above than our required value. 2.5. 2.6. 2.38. Yes, this resistor we need here. 2.37. Yes, this resistor we will replace. We will replace this resistor, that is low side resistor. Do you think it is good to modify the circuit? Please write in the comments, and then I will discuss can we modify it. Yes, now I replaced this resistor and now we will check the output. Yes, this is that which my viewer asked that he need this voltage. Now we have spare headroom to adjust the voltage up to 17 volt from 11.56 up to 17 volt. What are the positives and negatives of this modification? Let's discuss. When this power supply was working at 12 volt, at normal operation, for example, I will say it was using 10% duty cycle, and at that time it can provide 12 volt 10 ampere. That is rated output power. But now to increase voltage, what we are doing behind, we are increasing this duty cycle. Now without load, we increased this voltage, output voltage, by adjusting the resistor value. For example, I moved more 10%. Now I adjusted 20% duty cycle to take 14.2 volt. What will happen now when I will try to put load on this power supply? Before this, from 10% to 48%, there was a spare headroom, but now 20% to 48%, we have little space. In this portion it was providing 10 ampere, but now maybe it will limit it to 8 ampere or 7 ampere. When we will increase the voltage, the output current will decrease due to limitation in duty cycle. At that time, this power supply will not deliver power which it was delivering at nominal output. So this point must be considered before doing this modification. If you will force this power supply to produce more voltage, for example, I want 16 volt, maybe I will operate this power supply at 30%. At that time it will provide 16 volt. It's an example. Then I have very little space up until the maximum duty cycle, so I have just only 18% duty cycle. Maybe at that time this power supply will provide only 4 to 5 ampere. If you think we can perform this modification, let me know in the comment box. And if you think this video is informative, hit the like button. If you have any question, kindly write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.